Swayam Prabha. Digital India. Educated India.
Institute of Environment and Sustainable Development aims to promote environmental sustainability through research in various fields. Let's know more about the innovative works being done there by Dr. Prashant Srivastav and his team.
Obviously, we are limited simple regression model, but that is not very good in learning the data sets. So that's why we moved from simple regression model to AI/ML, artificial intelligence, machine learning, advanced model, and we are using a number of deep learning techniques. That is one of the most sophisticated technique in AI field of AI/ML to map the species distribution in Himalayan region. So if you see some of the work that we already given to NMHS and published, we are using this deep learning technique to map high value plant species in the Himalayan region. Similarly, we are using this deep learning and machine learning tool to build a model to predict chlorophyll in the crops. So what happened? We have the satellite images, we have the reflectance from the satellite images, we put in our machine learning model get trained and then start giving you the outputs like forecasting, and we know that this much of the chlorophyll will be there in the leaves. So we are extensively using this AI/ML technique to forecast our parameter of interest. For example, sometimes it is a chlorophyll, sometimes it's leaf area index, sometimes it's species distribution over there, sometimes it's crop type discrimination. So we are more into this machine learning model for prediction of crop or forest parameters. Similarly, this drone, we have a number of sensors installed in this drone, and we have a thermal sensor, we have a visible infrared sensor like red, green, blue, infrared and red edge, and all the sensors are actually related to the crop health. So what we are doing, we are flying this drone over our crop area, which is in our agriculture field here only, and we have some field other site like IIT and Institute of Vegetable Research, and then we also adopted some farmers field. Over there, every 15 days we are going for the field sample collection. Whatever we are predicting from the satellite, we are also measuring at the ground, and we see whatever predicting from the satellite whether actually it is matching with the ground. If it is matching good with the ground, it means our algorithm is working well. If it is not matching well, we are remodifying our algorithm so that it can predict the ground things very clearly. So every fortnightly, you can say, we are going to the field, we are having all the chlorophyll data, all the leaf area index data, and then we are comparing with the satellite measurements, and then we release our product. So it's a very extensive protocol that we are following, because this type of protocol is required whenever you are releasing any product or algorithm. If it is working well with your ground acquired information, then your algorithm is good. Otherwise, you need to relook your algorithm. Similarly thing we are doing with this drone, we are mapping it in all the sensors available. We are putting our machine learning algorithm, like one of the algorithm is like CNN, convolutional neural network. That is one of the deep learning algorithm. We are using this algorithm to map crop diseases. So recently we have mapped some of the important paddy crop diseases like blight, because it is whenever this blight coming, we are having a low production of rice in that season. So how we can map the you can say start of that disease mapping. So we are flying this drone on some of the sites. We are trying to see what are the signature changes whenever that disease happen, and we are trying to see with our sensor whether it is a change in the temperature with the thermal sensor, where there is a change in the leaf chlorophyll content or leaf color, and that we map using this drone and high resolution satellite data sets. And after that, we put our machine learning algorithm wherever we have having that type of signature. Machine learning just take that signature and predict at a larger area, and this way we are saying that this much of the area is infected by this particular disease, and you need to spray as soon as possible your pesticide or any other thing that is required to control that disease and this way we are helping farmers and the scientists over here so that they can go for their further analysis. Okay, so in another project that we did in last year only with Australian government, it is one of the important project because there are a number of forest fire event going in Australia, and we are also witnessing such type of forest fire happening right now in India also. So in that project or work that I worked as a visiting scientist in University of Sunshine Coast, Australia. Over there, we develop some of the recent models, like how we can see what are the changes happen due to forest fire. Can we predict some of the forest fire beforehand? Because whenever there is a temperature rise, if there is a fuel present in that forest, then there is a chance of forest fire happening. So how we can map that fuel load? Because here fuel doesn't means like it's a kerosene or diesel. Fuel over here means what is the amount of liter over there, is that leaf, drying leaves having oil in them, if what is the thickness of that liter, and that all impact our forest fire. So when what happen whenever there is a high temperature, high sunlight, if there is oil in the leaves, that leaves is dried, then it is and they are catching that fire very easily, and that leads to forest fire event. So what are the things that can be used by satellite means, so that we can map all those fuel load in advance, where we have a high fuel load, where we have the low fuel load, where if we can identify the pockets where we are having a high fuel load, we can reduce some of the fuel from here, removing litters and other content, so that we can prevent this forest fire events. So over there, what we are doing, we are using some of the recent satellite like S-band NOAA satellite is one of the important satellite in Australia. Then we are using some of the European satellite like Sentinel-1, Sentinel-2, and we are measuring high resolution fuel load in the Australian region. And similar type of things we are also now trying in the Indian region, because we are having a lot of forest fire event. And this type of technology, if we adopt here, then we can actually help government to save our precious resources, because whenever this forest fire event happen, we need to move locality over there. It also harm wildlife over there. We also having loss in flora and fauna. There are a number of things like pollution, air pollution, several things happen. So how we can control all this advance? So if this type of technology like based on the Sentinel-1, Sentinel-2 implemented over here, then it can reduce some of the forest fire event in the Himalayan region or other region where in the Uttarakhand, where we are having this type of event. Another project that is we are right now working is funded by it's a bilateral program between India and Japan, funded by ICSSR and GSPS, Japan Society for Promotion of Sciences, and Indian Council of Social Science Research. Both ICSSR and GSPS funded this project. In this, we are building a high resolution mapping of this soil moisture load, or you can say fuel load over here. In this, we are merging that coarse resolution, like as I told, SMOS is very coarse resolution, that is not good for local application because its size footprint is very high, and other data set which has very small size is very good, resolution is very good, but their scale is not that good because it is covering very small area. The problem is like one is giving a large area, global area coverage, but problem with that global area coverage is that it is not suitable for local application, and one which is having a local application but that is not covering the global. So how we can merge both to get the advantage of the global coverage as well as the local coverage, and also advantage of the temporal, because what happen if there is a forest happening in 7 days and your satellite is passing after 16 days, then it will be of not very benefit. Why? Because forest fire happened in 7 days, but your satellite is coming after 16 days and event is over. So how we can bridge that gap? How we can provide product at a high temporal resolution? We call as if we provide every 2 days, 3 days, 5 days, then it will be very good for policymakers. So what we are doing in this Indo-Japan project, we are merging this high resolution radar with coarse resolution radiometer to give high spatial as well as temporal resolution product. So now we have very good mapping of the ground at very high resolution. It is very good for local application, as well as we are also improving this temporal time period resolution. So now the policymakers, the users can have this product and use it for like protection of our natural resources like forest. So here we are focusing more on the forest, how we can use it for the Japan as well as for the India, so that we can develop this type of product for forest fire event, soil moisture irrigation, then forest eco hydrology, then wetland conditions. So many things this product can be used, and that's why both India and Japan are interested in this project. And we started with this project with the Hokkaido University, Japan, and soon there will be some result that will be shared through our university portal. Water quality is one of the major issue in India because it is getting contaminated because of so many activities going on in India. And water quality, if it's getting down, that will impact our irrigation water quality as well as our drinking water quality. And that's why there is a lot of challenges facing by the people over here, how to get a clean water for their daily need. And some of the solutions are there like RO and other thing, but that is not a sustainable solution, we all know. So how we can monitor this water quality on a regular basis, that is one of the important challenge. And in this work what we are doing, that is funded by ISRO, and our partner is from IIT BHU. We are mapping this Ganga river water quality on a periodic basis, and we are developing automation schemes, AIML based scheme, so that we can provide the situation of water river Ganga water quality based on our satellite and drone data sets. So we are regularly going to the field. We are taking the drone data of river Ganga. We are also taking the satellite data sets, and we are developing a dynamic model so that we can give water quality changes in the water quality at a daily scale. When this water quality is changing, is there is contaminant is coming in the water quality, that can provide to the policymakers, and based on that they can have some of the preventive measures, so that then they can control that water quality issues. Because sometimes there is a news couple of years back that river Ganga water is going green. And why does it going green? Because of some of the activities affecting that water quality of the river Ganga. So if we can map all those water quality parameters like changes in the temperature, pH, color, then turbidity, solids coming in the water, that we can provide some of the solution to cure all those problems, or at least prevent all those problems. So in this work we are regularly monitoring all the parameters in our laboratory, that what are the water quality parameters of this river Ganga. We are also building algorithm based on the satellite and drone, and then we are comparing whether our drone and satellite based algorithm is actually able to predict that river Ganga water quality or not. And we are happy to say that we are at a quite satisfying degree of level, we are able to predict river Ganga water quality based on drone and satellite data sets. So this is my remote sensing laboratory, where we are working on number of research areas. As I mentioned, we are working on microwave remote sensing and then hyperspectral remote sensing for different applications. And here you can see students are working on different software programming languages to develop their things. They are also working on image processing aspect so that they can map the things accordingly. Here you can see student is working on the species distribution modeling and the mapping of different species in the Uttarakhand region. Over here he is working on landslide disaster monitoring by using space technology. And here you can see that person is working on crop type discrimination and hyperspectral data analysis by using different type of advanced sensors like Nmap and Prisma. And through all these activities we are doing all these projects. They have their own ideas as well. We have our ideas that we already get funded from some of the reputed funding agencies from India as well as abroad like Australia and Japan. So this is the overall work that we are doing over here.
Actually, as we know, it is not possible to go every field and to collect the data. So we use the remote sensing techniques, and I have used most advanced remote sensing satellites like FVSNG, Prisma, and in map data. And you can see this in my research. I have done various types of work, and these are the satellites data I have used. and I have generated some spectral libraries. As we know, every person's have signature is different, and for the crop also it's like that only. We can collect the spectral signatures, and we can identify the pigments, what are the, like ki why leaf color is green, because of chlorophyll. So these parameters we can retrieve using remote sensing also. We don't have to go on the field and we have to collect the data. This is all the don't require. We can do the these analysis in the lab only for the larger area. So I have done these types of work for the Varanasi also and for the Gujarat also. And these are the classification map I have done. I have published the what are the crops are there, and which are the healthy crops, which are the unhealthy crops, and which types of fertilizer and water we have to give. And these are all are I have to done in my research. And also I have done the most unique work. I have developed the tool. In this tool, like everyone is don't know about the programming, so I have developed the tool. Using this tool, you have to just give your data, and it will tell about your crop growth and analysis, and it will give the simulation about the how crops are affecting with these parameters. So what I am telling, in my PhD research, I have developed one more unique toolbox, like crop stage simulator. In this toolbox, every non-programmer also use this toolbox. In this toolbox, you can give only your field data, and it can retrieve automatically your crop parameters. You can know about the crop health, how crop is growing, and what action you have to take in, and which stage you have to take the action. So in this parameter simulator, you can give, and you can know the crop stage variations, and you can understand what is the which parameter is affecting, like leafy index, chlorophyll, and other parameters also. Whatever research I have done in my PhD, and I have learned so many things. I can use so many satellite data, and this data I will use in my PDF research to develop new types of tools, and which can use for the and these tools also use can for the normal layman also they can use, and they can retrieve the parameters, and they can know about the crop health.
बेसिकली काम है वो क्रॉप सिमुलेशन मॉडलिंग पर है, और मैं उसमें ये मतलब काम कर रहा हूँ कि टोमेटो का जो मतलब प्रोडक्शन होगा, यील्ड होगा, जो उसका उत्पादन होगा, वो आने वाले 50 सालों में या 40 सालों में कितना घटेगा, कितना बढ़ेगा, जो कि ग्लोबल वार्मिंग का जो इफ़ेक्ट पड़ रहा है। आजकल हम लोग सुन रहे हैं कि ग्लोबल वार्मिंग, टेम्परेचर इंक्रीज़ होंगे, कार्बन डाइऑक्साइड इंक्रीज़ होगा, सोलर रेडिएशन इंक्रीज़ होगा। जैसे कि कई सारी रिपोर्ट्स आ रही हैं आईपीसीसी की। आईपीसीसी का फर्स्ट आया, सेकंड आया, थर्ड आया। तो मेरा मैम जो बेसिकली काम है वो आईपीसीसी की जो रिपोर्ट थर्ड है उस पे है बेस्ड। तो उसमें मतलब जो चीज़ें जो बताई गई हैं मैम, उस पे मेरा काम है कि मतलब जो टेम्परेचर और कार्बन डाइऑक्साइड इंक्रीज होंगे तो वो टोमेटो के यील्ड पे क्या वो प्रभाव डालेंगे आने वाले सालों में। और मैम मेरा जो काम करने का जो साइट है वो पूरा एमपी है। मैंने एमपी इसलिए चुना था कि 4-5 सालों में जो मध्य प्रदेश है वो हमारे देश का सबसे मतलब लीडिंग स्टेट है टोमेटो प्रोडक्शन में। अभी जैसे कि एनएचबी की रिपोर्ट आई है तो उसमें उन्होंने बताया था कि 21-23 में सबसे ज़्यादा टोमेटो का उत्पादन हुआ था वहाँ पे। और मैम अभी मैं फर्स्ट ईयर स्टूडेंट हूँ, तो इसलिए मैम मेरे जो ऑब्जेक्टिव और भी जो बने हैं, तो मैम जैसे कि हम देखते हैं कि जो फ्रिज में हम टमाटर रखते हैं तो क्या होता है कि 2-3 दिन बाद वो सड़ना चालू हो जाता है। उसकी जो स्किन होती है वो बहुत मतलब थिन होती है, पतली होती है। तो मेरा ये भी है कि मैं उसकी प्रोसेसिंग पे काम करूं, कि मैं कुछ ऐसी वैरायटी डेवलप करूं जो कि इंडियन वैरायटी हो, हाइब्रिड ना हो, वेगर वैरायटी हो, कि आने वाले दिनों में कि वो 4-5 दिन तक वो स्टोर करके रखा जा सके। कि अगर हम जैसे फॉरेन कंट्रियों में कि लोग 10-10 दिन, 15-15 दिन, उनके पास ऐसी वैरायटीज़ हैं। और मैंने मैम टोमेटो इसलिए चुना कि चाइना के बाद इंडिया ही है, भारत, जो कि टोमेटो में मतलब सेकंड लार्जेस्ट कंट्री है टोमेटो प्रोड्यूसिंग। मैं जो क्रॉप सिमुलेशन मॉडल कर रहा हूँ जिसका नाम है डीसैट, डिसीजन सपोर्ट एग्रो टेक्नोलॉजी ट्रांसफ़र, उसका फुल फॉर्म है। तो मैं इंडिया में फर्स्ट पर्सन हूँ जो कि ये टोमेटो पे काम कर रहा है।
I'm working on soil moisture estimation. As we know, soil moisture is a very important factor for soil erosion, drought monitoring, forest fire, and agriculture, and it's a crucial part of hydrological cycle. So we are trying to develop a model which uses a multiple satellite information. And soil moisture estimation is very difficult to measure because it's a cost intensive and human resource intensive, and we can't deploy the sensor in the field across the India because we have vast field on which agricultural practice is done. That's why we are trying to develop the satellite based information and train the model and predict how well we are able to predict the soil moisture in the field, because we don't want to deploy the sensors and invest. So we are cutting down the cost. At the same time, we are developing a cheap model using the machine learning and deep learning and getting the right information through which we can inform government, agriculture practitioner like farmer when they want to irrigate their fields. Machine learning and deep learning is an emerging technology, and people are using it for soil moisture estimation across the globe. Here we are doing it for Banaras region, but we believe that since our results are very encouraging, we believe that if we go for the extensive data set, we can develop a model which will help the in the prediction of soil moisture on a daily basis, because the satellite is retrieving the data daily basis. And that's how we can develop a model which can be used for informing the government and farmers, and then they can plan their irrigation accordingly, and that will minimize the water consumption. At the same time, it can increase the yield of the farmers.